Today we're going to talk about how to prove a square in coordinate geometry. Again, please make sure that if you chose not to print out the notes, that you take out a piece of loose leaf paper and a piece of graph paper so that you can work along with this proof. So the first thing that we want to do is go over all the properties of a square. So if we think about a square, and if you're getting the hang of what we're doing with the other properties, a square has all the properties of a parallelogram, which means the opposite sides are congruent, the opposite sides are parallel, consecutive angles are supplementary, opposite angles are equal, the diagonals bisect each other, the diagonals form two congruent triangles. Your square also has all the properties of a rectangle, which means that it's got four right angles, the diagonals are congruent. It also has all the properties of a rhombus, which means that all four sides are equal, the diagonals are perpendicular, and the diagonals bisect the angles. So if we're thinking about doing a proof, again, the first thing we want to do is go over the properties. It's got all the parallelogram, all the rectangle, and all the rhombus properties. So when I do this proof, the first thing I'm going to do is graph the picture. So I've got 4, 1, 1, 5, negative 3, 2, and 0, negative 2. And that's L, M, N, and O. Now there are several ways that you can prove a square. I'm going to go with the easiest way, and that's with our distance formula. So my plan is I will use 6 distance formulas. And think about what those distance formulas are going to show. To show all 4 sides are congruent. That tells us it's a rhombus. And the diagonals are, sorry, I think I hit a button there. So we're going to show that the diagonals are congruent as well. So the first thing we want to do is write down our distance formula so that we have something to refer to when we're plugging in the coordinates. So that's x2 minus x1 squared plus y2 minus y1 squared. Hopefully at this point, you kind of have that formula memorized. Now, if we think of the 4 sides, it's L to M, M to N, N to O, and O to L. On top of those 4 sides, if I look at my diagonals, we'll do them in blue. My diagonal is NL and OM. So we also have to do NL and OM. Again, I'm going to hit pause while I do the work. You might want to hit pause on the video and try them on your own. Okay, so I did all of the distance formulas while the video was on pause. And if I look at it, side LM is 5, side MN is 5, side NO is 5, and side OL is 5. That means all 4 sides are congruent. When I did the diagonals, I get that side NL and OM are also the same length, so they're congruent. Now I have to write a conclusion to explain to the person who's reading this what all of this math means. So what I'm going to write is since the lengths of all 4 sides of quadrilateral LMNO are 5, they are congruent. Since the lengths of the 2 diagonals are each, you can write either radical 50, or if you chose to simplify it, 5 radical 2. So you're going to pick one, this one, or this one, not both. They are congruent. Then you're going to explain. So what does that tell you? That tells you that a quadrilateral with 4 congruent sides and congruent diagonals is a square. Therefore, quadrilateral LMNO is a square. Again, there are a couple of other ways that you could have done this proof. I'm trying to keep it short and sweet. So far, the 4 shapes that we have covered can all be proven using the distance formula. So if you become the master of the distance formula, you will be the master of these 4 proofs. Any questions, please make sure you email me or write them down and ask me next time you see me.